This Zoom session is being brought to you by the fractal inverse bullseye bubble cactus black. For today, we will be doing 8-4 graphing quadratic functions and 8-5 quadratic and other nonlinear inequalities. Okay, quadratic function, well, it'll be of the form y equals ax squared plus bx plus c. Starting with the simplest one, y equals x squared, its graph is this U-shaped curve called the parabola. You've seen it before. It's visible in suspension bridges, and when you throw something through the air, it goes through its trajectory is parabolic. Back in the olden times when we were there in person, I would throw an eraser across the room just to show what a parabola looked like. But whatever. So it's this U-shaped curve. Ax squared, y equals ax squared. Well, it's the same kind of roughly cup shape, but depending upon a. If a is positive, it's cup up. Here's a graph of a of y equals 2x squared. Here's a graph of y equals 1x squared. Here's a graph of y equals a half x squared. If a is negative, then it's cup down. Y equals negative 2x squared has this graph. Y equals negative x squared has this graph. Now, if you take this and shift it h units right and k units up, here's the equation. Y equals a times x minus h squared plus k. This bottommost or topmost point is called the vertex. And it's a U shape up or down. Now we can complete the square. So if we have y equals ax squared plus bx plus c, then we can rewrite as a times x plus b over 2 squared plus a constant, which turns out to be f of negative b over 2a. So it has a graph with a vertex negative b over 2a by f of negative b over 2a. Cup up if a is positive, cup down if a is negative. If a is positive, then this is a minimum graph, a minimum of the graph. The minimum value of f is f of negative b over 2a at x equals negative b over 2a. If a is negative, so it's cup down, then the vertex will be at the top of the curve. So it will be a maximum value of f equals f of negative b over 2a at x equals negative b over 2a. Oh, by the way, in any maximization or minimization problems, you will be asked for what the x value is, which is where the maximum or minimum occurs, and the y value is, which is what the minimum or maximum value is. So these will both be required. So for example, find the vertex and the concavity for y equals negative 2 times x plus 3 squared minus 4. Well, you can read off this x plus 3 is x minus a negative 3. So the vertex is negative 3 by negative 4. And because this is negative 2, it's cup down. Excuse me, I'm being, oh dear, Lopez. Well, who else? There was someone else. Okay, never mind. Sorry, interrupted. Okay, here we have asking vertex and concavity for 2x squared minus 4. This is x minus 0 all squared minus 4. So it's 0 by negative 4. And because this is a positive 2, it's cup up. Here we have y equals x squared plus 4x plus 5. All right, to find the x value at the vertex, it's negative b over 2a. That's negative 4 over 2 times 1, which is negative 2. If you plug negative 2 in for x, you get after a bit of churning, y equals 1. So the vertex is negative 2 by 1, and since it's a positive 1x squared, it's cup up. Here I have the equation y equals negative x squared plus 6x minus 15. Okay, for the vertex, we need negative b over 2a, would be negative of 6 over twice negative 1, negative 6 over negative 2, which is 3. If you plug in 3 into this equation, churn, 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 out comes y equals negative 6. Because it's the negative of 1x squared, that means it's cup down. So the vertex is 3 by negative 6 and cup down. And here we have y equals x squared plus 2x minus 3. Complete the square, find the vertex, and is it cup up or cup down? Y equals x squared plus 2x minus 3. So here we go. Y equals x squared plus 2x minus 3. Move this minus 3 off to a bit. And to complete the square, we take half of this middle coefficient. That'd be a 1. Square that is a 1. Add and subtract back in. X squared plus 2x plus 1 minus 3. These three terms will be x plus 1 all squared And minus 1 minus 3 is a minus 4. Okay, read this as x minus a negative 1, and here's a minus 4. So the vertex is at negative 1 by negative 4. Since this is a 1, positive 1 times the square, it's kappa. Here we have y equals negative x squared minus 8x minus 17. Here, because of a negative, they'll be cupped down. In fact, let's pull this negative out from these first two terms. The opposite of x squared plus 8x. Leave the minus 17 outside. To complete the square, take half of this coefficient 8. That's a 4. Square that, it's a 16. And add and subtract back into the same parentheses. Minus of x squared plus 8x plus 16 minus 17. Now these three terms, x squared plus 8x plus 16, is x plus 4 all squared here. Just a second, man and hand. Apologies, I have to make a note. There we go. And so minus of x minus plus 4 squared, minus 16 minus 7, minus a negative 16 is plus 16, minus 17 is a minus 1. So y equals minus of x plus 4 all squared minus 1. Now again, this is x minus a negative 4, so really you have a negative 4 by this gives a negative 1. Because of this, it's cupped down. Find the vertex of 2x squared, y equals 2x squared minus 3x plus 4, and graph. All right, for the find the x value of the vertex, it's negative b over 2a, that's minus a negative 3, or twice 2. That's 3/4. Plugging in 3/4 in, you get y equals 23/8. So the vertex is at 3/4 by 23/8. This a is positive, so it's cup up. So here we go. The vertex is at 3/4 by 23/8, and it's cup up from there.